is at least part of the personnel in the Swedish consortium, and you see that the companies are ABB Bombardier, who is the global coordinator of the project, also, and Adiva, which is a small SME in Västerås, as well as Percipio, and Mellon University and RISE. So what is the justification for this project then? So the majority of industries produce not only one single product, and even the products that they produce often show up in lots of variants. For example, it's stated here that a car on the line is often, during one day, there is often not two single cars that are similar or identical, because the customers have been able to make different kinds of choices and variants of it. It could also be that if you sell a product into different markets, that there are different kinds of regional aspects and standards for it. And also, as a last example here, is that also the customer could ask for customization after deployment. So in the end, we have a rather complex situation for each company, where you perhaps have, do you have some kind of, yeah, we have several products, and each product has, I'm not very good at this, could have different baselines for different markets and so on, and also even different variants in each of them. And for each product, of course, there are also several levels to take into account. So this is a picture of how a baseline could be instantiated in different variants. So in one single baseline, there could be features that are actually present in a variant, but there could also be features that are not present in any of the variants. And there could be features that is present in the variant, but not in the baseline. And there could also be features that are altered when they appear in a variant. So there are many variants to take into account for a product. This makes quality assurance and testing very complicated and challenging. But on the other hand, it also opens up great potential for improvement and cost cuts to save resources and time in the process. So what we are covering here in this project, it appears from the picture here. That's a variability modeling and test optimization, and also test generation for these multiple variant rich products. And we are working in 4 domains: in rail, industrial production, automotive, and telecom. And we also, of course, have to take into account safety and security aspects. So currently, given this picture, a product, the kind of the baseline has to be tested together with requirements from different standards each time when you deploy a product. And this it makes the testing procedures expensive and for each time, and also that you have to repeat it for each instance. So XIVT will for this end define methods and tool chain for testing high configurable variant-rich embedded systems, and use knowledge-based analysis of requirements formulated in natural languages and model-based test generation on the product line level. And this should, in turn, enable a highly effective, cost-efficient assurance. And our result will also be models in open source packets for enhancement of existing domain-specific testing tools, and a tool chain and an ecosystem of several services around the proposed methodology. In this way, our methods will result in higher test coverage, more flexible processes, and higher quality and better products. So hopefully we will gain both in both ends with this technology. So back to the consortium. So these are the Swedish partners in the consortium, and all of us have a large coverage out in the world in different ways, of course. Bombardier and ABB as international large companies, and Adiva and Percipio, who are also through their customers present in many countries. And of course the academic and the research partners also, of course, have a large international presence. There is an increasingly tough market, and the competition is high in all these domains that we are talking about. So there is a high interest from both from all our domains. And the Swedish consortium, we contribute with two of the domains. With Bombardier and ABB, we contribute with domain knowledge and experience from rail and industrial production. And we also have technology knowledge in test optimization, test generation, and variability modeling and machine learning. And on the other hand, the Swedish consortium, of course, benefits from being in an ITEA project with connections through the world to the automotive domain and text execution, industrial security, model checking, and not least the wind tunnel in Canada. So this is how it looks like. So we have participants in Sweden, in Germany, in Turkey, and in Portugal, except for Canada then. We have a strong European consortium and hope for a lot of cross-fertilization between the different kinds of partners and the different domains. And it's typical for this kind of project also that we cover different domains. So we also will be pre-compatible and for the companies and so on. It also opens up the possibility to validate the tools in different areas, in different domains, in different countries and different regions. And also the possibility to scale the the learning-based testing. And of course the bridgehead in Canada is also an important feature in a project like this. An interesting extension for European projects, and Canada has also been rather active to take part in the European program, not least after the political development in North America. This is how the consortium, the value chains, looks like, more or less. We have the equipment manufacturers, the OEMs, and knowledge providers, and the tool providers. Here actually also Percepio is lacking in this picture, and service providers. And this is how we think that the Swedish consortium could work with these different blocks, and this is the communication through us. Everything starts with the needs of the OEMs, of course, that I explained in the beginning. The need of testing different variants of a product, and in this way the research will supply with knowledge for both tool providers and service providers. There are also of course non-commercial tools that are produced in the research organizations. So the project goals are now then to obtain a method and a tool chain for testing highly configurable variant-rich embedded systems in the automotive, rail, telecommunication and industrial production domains. And in this sense we will improve the test optimization to make test cases automatically in all these variants of a single product. Yeah, I think that's could be it for so long. And if there are any more questions on the technology, I think that some of the researchers here, like Merdad, could answer.
That's great.
Mm-hmm.
Thank you so much.
Thank you.